We continue with diffusion models. And in the last class, I wrote this lower bound, which is log bx is lower bounded by, and this we did this derivations, and what we got is this expectation of q1 q x1 x0 log of p theta x0 x1 minus KL of q xt x0 xt, and then minus of sum of t is equal to 2 to t q xt x0 and dkl q xt minus 1 xt x0, and then compared with p theta xt minus 1 xt. So we derived this in the last class. So this happens to be a lower bound. That's what we usually do in this kind of ideas. We get to a lower bound, and then we see whether we can have a tractable form, so that we can at least work with the lower bound, minimize that, maximize that, and we approximate the actual distribution. So this is something we derived in the last class, and then we continue from here. And just to recall, so the terms are as usual. The first term is a reconstruction term, the second term, and then this is the third term. So E q x1 x0 log of p theta x0 given x1 is a reconstruction term, but this is something we have already seen, so you can think of this as a revision. So basically we are reconstructing, this is our original data x0, and at least from here what it seems is that we are reconstructing from the first gradient, okay? But although we come way from t, x1 is here, x0 is here, so we are saying reconstruction from the immediate previous step, although we start from xt. Okay, so we call it reconstruction. And then this is, we have also seen, is a matching term. So, and this is the prior matching term. So prior is when we pick a distribution by ourselves. So in this case we say that in advance that this is what I want. Okay, so no matter how you come, this is the prior distribution that I want you to predict in the forward pass. So that's why it's a prior, and this is here prior. And then what we are saying is that from x naught I go to xt, so basically from here until here. So the way I predicted the distribution and the way this is our prior, which is usually standard normal. So this is the matching term that says that the way you predicted and the one I have fixed, how close they are. And then this is the third term. So this is the second term, which is so basically it says how close. So the second term is dkl q xt x naught q xt, and this represents how close the distribution of the final noisified input is to standard Gaussian. Okay. So we have I also remark here that the way we go forward, it's not a learnable process in the sense that we fix that we fix in advance. I mean, basically it's known how I'm going to go to x1 and then to x2 and so on, okay, by some fixed translation and scaling of the mean and the variance. Okay, so this process, forward process, is not a learnable one. And then the third term is the term we have also seen in the last class, that it's where you are trying to see the consistency. So xt plus 1 and xt minus 1. So it's the forward process and this is the backward process. And then you want to see whether these distributions match. So xt minus 1 going to xt, okay. So and then, I mean, the way we have written here is a you can say it's a little bit confusing because we formulated our original elbow, if you recall, where we had a t and t minus 1, but we used the base rule, and now we say that so this is basically an interpretation of the same thing, but by the base rule we reverse it. Okay, so it's like this. So let us say I have a ground truth, okay, which is the standard that I want to match. So that's why if it is available, okay, it may be hypothetical, okay, that's what I'm trying to say. So, and in fact we will see that it's hypothetical, so we will change it again so that in the next steps. So but this is a abstract setting right now, still not tractable. So what this is saying is that there is a ground truth which is the hypothetical Q, which is the gold standard, and this is something I am trying to learn by myself. Okay, so basically I'm trying to match that, the gold standard compared with the approach we have. Okay, so and in the previous elbow formulations we had this, we wrote it like this. Okay, so these are like different ways to see the matching. Okay, so we will continue from here. We will specifically we will focus here, which basically involves most of the work, and this again will have closed form expression because these are Gaussian. Basically here everything is a Gaussian. Okay, P, Q, all are Gaussians here. So the fact that all are Gaussians, whenever you have the KL terms, they will have closed form expressions. Okay, so this we did in the VAE form as well, but here we have to do some work because it's not yet tractable. So this is the goal. So let us continue from here, and let's see what we can do. Basically we will understand computational aspects of all these terms today. Okay, how actually we will work with this. So the first step we are going to do is we will change it, flip it via the base rule. Okay, so that's one of the steps we are going to do. And second thing we will use is that these are all are like standard normal. So even these guys are standard normal, but here this has to kind of learn the parameter. So this will be standard normal mean and variance predicted via the neural network while going in the backward way. So all these things have to be fixed. So the first step I'm going to do is that I will apply the base rule here. Okay, and so if I apply the base rule here, so to make the optimization tractable, using base rule, so Q xt minus 1 xt x naught can be written as Q xt given xt minus 1 x naught xt minus 1 given x naught, and divided by q xt given x naught. So we have applied the base rule, and from here, what are the things? So even after applying the base rule, then we look into the terms on the right hand side of the base rule. So can we compute q xt xt minus 1 given x naught, and similarly can we compute q xt minus 1 given x naught and xt given x naught. So what we know for sure is that all are going in the forward way, which is a good thing, because here I'm looking for xt given xt minus 1. So it's like a forward step. This is forward step, and this is also forward step. So in the forward step, we have predefined the way we are going to change these distributions, right? So we will try to explicitly, with the view that we know how to translate these guys. So we will try to put those and see the expressions for these q. So so here what we know is that going to t from t minus 1 is a so going from t to t minus 1 to t, by our assumptions, it's a transformation of the mean and the variance, okay, in a predefined way. So so with that view, we can write this as what could be the distribution it will be, right? So q xt xt minus 1 x naught, and since this is Markov, so this is q xt given xt minus 1, and this is normal of xt and square root of alpha t, xt minus 1 and 1 minus alpha t identity. So this is how we define the transition from xt to xt minus 1 to xt, okay. So remember, this is xt minus 1. So using xt minus 1, we are getting the samples xt, okay, by doing this scaling and then and scaling of the variance and so on, okay. So this is a predefined way, okay. So you may say, why this? I say, let us take this, okay. So this is our predefined way to go that way, okay. You may play with some other translation as well, right? So this is what we choose. This is how we are going to move t to t minus 1 to t and so on. So this is our distribution, and what we don't know is the t from x naught, right? So what would be this distribution xt given x naught? So it's like there may be a big jump here. So t may be very far away, and yet I'm supposed to predict or compute the expression q xt given x naught. So we don't know these guys, xt given x naught, or even this. So we don't know. Okay, so we will try to like figure out all those. So the only thing is, like, when I go to xt from x naught, it's a t steps to go to xt from x naught. So and we do know this one step at a time, the translations that happen. So it's like somehow we have to find some cumulative until t, right? So this is the view we have. So, and we can see each of these one step at a time as kind of a reparameterization, right? So we know that we can obtain a new Gaussian with a specified mean and variance by doing some translation of the mean and the variance. So we are going to use that. That's essentially reparameterization trick again. So we are going to find these things with the view that we go step by step with these translations and so on. So let us do that. Basically, all the calculation goes in finding the closed form expressions for this. We know that all are normal, but what exactly the KL of these become, right? So it's more of an algebra here, okay? Not too complicated. So the terms Q xt given x naught and Q xt minus 1 given x naught are made tractable, okay, due to the fact that encoder is transitions of a by made tractable by using the fact that encoder transitions, okay, so that's the correct word, of variational diffusion models are linear Gaussian models, okay. So under reparameterization trick, any sample xt can be written as xt is equal to square root of alpha t xt minus 1 plus 1 minus alpha t and epsilon, where epsilon comes from standard normal. So we know very well that to get a normal distribution with prescribed a mean and variance, we can obtain it via standard normal, okay. So this is something which is well known. One can check that this will have the mean alpha t and variance 1 minus alpha t, okay, because you're supposed to do the square here. So this is like a sigma here. So this is a common thing we also saw in the probability class, that this is how we can obtain a given normal distribution. And similarly, we can also say this for xt minus 1. So similarly, and so means at for the it's just that the indexing is now 1 minus, so it's the same thing basically. So this is how we view these xt, okay, relative to the previous xt minus 1. So now we know this step by step transition from t minus 1 to xt, and what we want to compute is this cumulative thing until xt from x naught, okay. So that's what we will try to compute, okay. So basically it's about applying this recursively, starting from x naught basically. So computing q xt x naught, it can be recursively derived through repeated applications of reparameterization, okay. That's what we know, the repeated applications of reparameterization. So basically to go to t, so we are looking at this to go to t from x naught, and each step of the forward will involve having one standard normal sample. So to go to t, we will need t of those epsilons. Okay, so those many noise standard normal noise vectors we need, and with the help of that we will propagate this to t plus 1 and so on. So as an auxiliary I will also use capital T of these, and I will see where until where I can go. Okay, so technically T is going up to T, capital T, right? So hence, so it's like capital T. So essentially I want in hand capital T of these epsilons. So okay, because although I say T is arbitrary, but okay, I can take those many of those capital T of those samples, and I will also use some auxiliary epsilon star. So then suppose we have access to 2t. Okay, so I will take one more. Okay, actually, so we will see how all this will be used. Okay, so capital T random noise vectors variables, and let us call them epsilon star t and epsilon t. Okay, so and these are t equals to 0 to t, and they all come from these standard normal. So now let us work out this. So let us start with this xt. So we want to see, we already know that xt, how it comes from xt minus 1, and we will keep doing this recursively. Okay, so we know that xt is alpha t xt minus 1 minus alpha t epsilon star t minus 1, and we can apply this recursively. So now I can do the same thing for xt minus 1. So then this becomes square root of alpha t, and then square root of alpha t minus 1 xt minus 2 plus square root of 1 minus alpha t minus 1 and epsilon star t minus 2 plus 1 minus alpha t and epsilon star t minus 1. So I basically applied this recursively. So xt minus 1 will be a square root of alpha t minus 1 xt minus 2. Okay, that's how you see this, and so on. Okay, so t everywhere becomes t minus 1. So basically we can keep doing this recursively until we hit x naught. Okay, because that's where our real data is. So everything gets propagated from x naught. So we can apply this recursively until we hit x naught, where we actually know the data. Okay, these are intermediate values. So we do this recursively. So then we will see a product of the alpha. Okay, and if we do this recursively, then continuing, then what we get is, okay, before continuing, there is a simplification that is needed. There will be some cancellations that will make our lives easier. So for example, here we here itself we will simplify a little bit. So let us first simplify. So if we do this, then we will multiply alpha t. So if we multiply alpha t, then it becomes alpha t minus 1 xt minus 2 plus alpha t minus alpha t minus 1, and then epsilon star t minus 2 plus 1 minus alpha t and epsilon star t minus 1. So basically what we have done is that we have simplified a little bit, but what we observe is that we are summing up two standard normal. Okay, and then with some scaling of each of these, right? So So we know a result that that any alpha z1 plus beta z2, if z1 and z2 are in this case even standard normal, so this is still a standard normal. I mean not a standard normal, I mean just a normal, okay, with some mu and sigma. So this is the result we are going to use. So these last two terms will be a normal distribution, but because of the scaling that is done, they will produce some mean and variance, but mean will be still 0 because we did not do the scaling. I mean translations is missing here, it's like 0 plus something times this. So this, and this is all, this guy is also 0 plus sigma times this. So the mean of the sum of the these, if they are in this form, so the mean is guaranteed to be still 0. Okay, so these are the facts we recall, and sigma will change now. Okay, because of the scaling, sigma will certainly change. So this will be a normal distribution with mean 0, and variance will be sum of the variance. So this is a result. Also we know the variance of this is equal to the variance of this plus variance of this. Okay, so this is the fact we will use, and basically the variance of this will be a square of this. This is a standard deviation, this is standard deviation. So this squared plus this squared, and then we take the square root again to denote the standard deviation of that. So what we observe here right now is these guys can be written combined and as some standard, I mean not standard but normal distribution with mean still 0. So let us do that. So this is the first term remains same, alpha t minus 1 x t minus 2 plus, and as I said, this is variance plus variance, and then since this is a new distribution with 0 mean and the variance is known, which is variance of this plus this, we can again use a reparameterization saying that if I have to produce a normal distribution with mean 0 and variance, this is sum of the variance of this, then it can again be written as some mean plus variance of a new epsilon. Okay, so that's what we are going to do now. It's again a reparameterization thing going on here. So I am asked to produce a normal distribution with mean 0 and variance which is given there. Then I can say, oh, okay, so let me do the reparameterization. I take a sample from the normal, standard normal, and then if the mean you have given is non-zero, I will add that. In this case you have given 0, so it's 0 plus and the standard deviation sigma, which will be the square root of the variance, and that will be the normal distribution for this. Okay, so that's what we are going to do this. So this will be so to make a sigma, I have to make a bigger square root, and within that I know the variance of this is sum of the variance. So variance will be square of the standard deviation. So here, so we do that, alpha t minus alpha t minus 1. So square of this plus 1 minus alpha t square of this, and as I said, we will use some other variable where it comes from standard normal. Okay, so now if we do expand this, then some cancellations happen. So basically alpha t gets cancelled because after the square you can notice that there is alpha t and there is minus alpha t. So that simplifies a little bit, so it's good to do this. So this is alpha t minus 1 x t minus 2 plus alpha t minus alpha t minus 1 plus 1 minus alpha t and epsilon t minus 2. This alpha t gets cancelled. So then we can write this simplified one. So this is alpha t and alpha t minus 1 xt minus 2 plus 1 minus alpha t minus 1 epsilon t minus 2. So there is no more simplifications to be done here. So basically from here onwards we can do the recursion. So basically from t to t minus 2 we see that, okay, which is a simplified form. So we can run this recursion now. So xt is being parameterized by I mean, to produce xt I use a reparameterization trick, which means that I need 1, but then I also need for xt minus 1, right? This is for xt minus 1. Yeah, that seems to be a good point, right? Let's see. So did I use I think I will not end up using all of them. It's more of a notation thing, I would say, like I take excess maybe, but so you're right that epsilon star t I don't use specifically here immediately, okay? So I use epsilon star t minus 1 which is there, epsilon star t minus 2 which is there, epsilon t minus 2 I have used, and so on, right? So you're right. I mean, I have taken access to them. This comes for free, so I don't mind having them. So, but yeah, if we want to be more specific, then maybe we can say that epsilon star t minus 1, and maybe at some step we will need epsilon star t minus 2. Yeah, it's there. Okay, so epsilon star t minus 2 maybe we will need. Yeah, some are not used. Okay, I agree. Okay, they will never be used. Okay, because after here I will make a recursion. So this will be product, and these guys themselves will go to alpha 0, and yeah, we have to see what happens to these guys. So there will be product here also. So let us do this recursion. So basically we do this, continue this, and we have to go until 0, right? So if you go into 0, then the pattern here is that these products are being accumulating, right? So there will be product sign here, and obviously there is a product sign here. So after, okay, so if we continue this, then we end up as square root of product of I equal 1 to t and alpha I x naught. So this product is only for the alpha I, okay, and then plus square root of 1 minus I equal 1 to t, and then this is alpha I, and then epsilon naught. Okay, so continuing then we get this, and epsilon naught is outside, okay, and this x naught is outside. So what is this telling us is that epsilon naught obviously is standard normal. So basically the mean will be 0, and variance is a square of this. So we have to figure out, because x naught is also being applied with this scaled via this, right? So we have to write down the overall form for this. So this will be xt plus this guy, which we denote as alpha bar. So I have not denoted this. Okay, anyway. So this product, I will write this as, simplify this further as alpha bar t. Alpha bar is like this product, okay, and x naught, and then 1 minus alpha bar t, and this is epsilon naught, and this will follow normal xt and alpha bar t, because it will pick the whatever the first term is giving it from as a mean, right? And then the variance will be 1 minus alpha bar t. Okay, so x naught is not a random variable, it's a constant, right? So these guys are constant. So, and this guy obviously is a random variable, so standard normal, and this is scaling this guy. So what does this mean from probability again, right? If I take a random variable, I scale it, and then I add something. So the thing that you add contributes to the mean. Now this guy has mean 0, so the total mean will be this plus 0. So this becomes the mean. Okay, and the variance, because this is a constant, so variance doesn't contribute in the and the constant. The variance of constant plus a random variable is still the variance of the random variable, right? So we know these things. So variance of a plus x is variance of x. So hence this guy has no role in the variance. So this, the variance is picked up only from here, and this is standard deviation, so the variance would be square of that. So we know a form of these. We were computing this, right? So xt we were computing, and this is the form of xt. Xt is a normal distribution like this, and it has cumulative alpha t's, square root of those, and 1 minus cumulative alpha t. Okay, so this is what we were looking for, and this is the expression we have. And same thing, we also had a term xt minus 1 in the base formula, and this is essentially the same, just the t becomes t minus 1. So basically we have found the expressions for the two terms here. So hence we have derived Gaussian form of qxt given x naught. Okay, and the same thing will apply for the other guy as well. So similarly we can find q of xt minus 1 given x naught. Okay, so these two terms are known, and so now these two terms are known, and in the base theorem we had the third term which is left, and the third term is xt minus 1 given xt. Okay, so let us calculate that. Yeah, so knowing x naught, the real data, the form of the normal distribution that you will have is like this, with the mean this and the variance this. So now everything is dependent on how you did the linear transforms. Okay, I mean the transforms that you did. So each time you use some alpha to translate the mean and the variance. So this was used, and then this was used. So basically alpha i's are used as a way to see the translations via this reparameterization. This was just a way to see how we propagate, and if I have to see the concrete form after the t steps, how the distribution will look like, then this is determined completely by alpha bar t. So these were the means to propagate. Okay, but if you see the actual form of the normal distribution, it's only dependent on alpha t and 1 minus alpha t bar. So this alpha naught is just a way to derive things. Okay, but ultimately there is no role of epsilon anyway. It is a hyperparameter, obviously. How you will propagate, so there will be a discussion on this. What would be your choice of alpha? So certainly it's a hyperparameter, but no matter what these are, the expectation is that you will end up as, so if I see this as capital T, so this is a small t, right, given x naught. So ultimately what I want is that q capital T x naught is like a standard normal. Okay, so what it means is that whatever the process you have of picking the alpha t, it should be done in a way that you arrive at standard normal. So meaning from here you can maybe make some guesses, right? If you choose alpha t to be constant, it may not work, because at capital T, these guys Okay, so these guys like kind of, if they stay constant, then you are not producing a zero mean, right? So obviously we will get into the more details of how these hyperparameters are chosen. But one thing to keep in mind is they are chosen in a way that this guy becomes identity and this guy becomes 0. Okay, so for the moment I will say that, but there is a good amount of discussion we will do on this. Okay, so now let us look into the remaining term of the base theorem, which was qxt minus 1. So we proceed to calculate q xt minus 1 given xt x naught. So this was the remaining term in the base rule, if you recall, and I mean this was the expression we were computing, and so this was the left hand side of the base rule, recall, and we are estimating it via base rule. So in the right hand side we had these two terms, this and this, and the third term will be a flip of this. Okay, so we are recalling essentially the base rule, and then we will see q of xt minus 1, q of xt minus 1 x naught, and divided by q of xt x naught. So what we have done with this guy and this guy we are done, and I mean even the other one is done basically, because we did this as a very first step, right? So basically what is left is just like putting the normal distributions here, a normal distribution of this we know, this we know, that we know, and doing some long calculations. Okay, so this calculation will be very long, so let us hold on. So what I will do is that I will write down this. First step is to just write down the normal distribution form of this. So let us do this carefully. Okay, so normal of xt square root alpha t xt minus 1 minus alpha t identity. So this is the expression for the first one, xt given xt minus 1. That happens with one step translation, and then this 2 we have derived. So this is normal it may be a good idea to, if you have notes to take, you can do that, because there will be some cross references, and I don't have the big board to hold, so you can take notes because we will cross reference. So, and we have the denominator term now. So the denominator term is xt, we have just derived all this, so alpha bar t x naught 1 minus alpha bar t identity. We have just written what we know, the form of the normal distributions, and so these are normal distributions. So the actual PDF of this will be exponential of x minus mean divided by the standard deviation and so on. Okay, so we have to recall the PDF of this. So the fact is, since all are exponentials, so exponential of x minus mean squared here divided by the standard deviation, and then exponential of xt minus 1 minus the mean whole square, and so on. So the fact that these are exponentials, these exponentials could be the powers of this could be accumulated. Okay, so this will be the x minus this plus xt minus mean of this plus or minus xt minus mean of this. Okay, so this is what we are going to do. So this is proportional to exp minus xt minus square root of alpha t. Okay, let's see. So xt minus 1 to 1 minus alpha t, and then plus xt minus 1 minus square root of alpha bar t minus 1 x naught square divided by 2 1 minus alpha bar t minus 1, and then minus xt minus square root of alpha bar t x naught squared divided by 2 1 minus alpha bar t. So as I said, we know that these are normal distributions, so they are written as exponentials. So we have just exponential of minus of the x minus mu, right? So this comes for this guy. Okay, the minus I've taken is the completely outside one. That's why I was a little bit confused. So this guy should be minus. This guy should be minus. So these two guys are indeed minus, and this guy is in the denominator. So minus minus will make it plus. Okay. We'll take half common. Okay, so let us do step by step. So let us say I take half common. So this is or it's like equal to xt minus square root of alpha t xt minus 1 whole squared divided by alpha t plus xt minus 1 minus square root of alpha bar t minus 1 x naught squared divided by 2 1 minus alpha bar t minus 1 minus xt minus square root of alpha bar t x naught squared divided by 2 1 minus alpha bar t. I have okay, then why am I putting 2 again? This was exactly the step. So that's right. So minus half I've taken common. Yeah, it's right. And then what I will do is I will separate out the xt and x naught terms which are alone. Okay, so xt and x naught terms which are alone will be separated out to keep the calculations a little bit simpler initially, and then those terms will be we will plug in those terms again, okay, later on. So that will be the next step. So this is exp of minus half, and then minus 2 alpha t xt minus 1 plus alpha t xt minus 1 squared divided by 1 minus alpha t, and then plus xt minus 1 squared minus 2, and then alpha bar t minus 1 xt minus 1 x naught divided by 1 minus alpha bar t minus 1, and then plus c xt x naught. And this is the term I was talking about, is that I will separate out xt and x naught terms which lie on their own. Okay, so in other words, you don't see this term alpha bar t x naught and then 1 minus alpha bar t, that went here. Okay, and the remaining terms like xt minus 1 square is there, minus 2ab form, so minus 2 xt minus 1 square root of alpha bar t minus 1 x naught is there, but the individual term x naught square by 1 minus alpha bar t minus 1 went there. Okay, similarly here xt term xt squared by 1 minus alpha t, that went in C, and remaining term, as you can see, it's here. So this is the thing we did, and for a reference, I think it's good that you put this in your note, although I do this calculation a bit later. So for reference, what we can do is, so here, okay, because we will bring this C later on. So here C xt x naught is xt square by 1 minus alpha t plus alpha bar t minus 1 x naught and then minus xt squared. We could keep, okay, anyway, let us do this separately. So xt square by 1 minus alpha bar t minus alpha bar t x naught square by 1 minus alpha bar t, that's the second term. And then the mixed term is also there. So plus 2 alpha bar t x naught xt divided by 1 minus alpha bar t. So as you can see, C is this term, okay. Basically x naught xt or a product of them, okay. So this is being separated out for the moment, but we will bring this term later on. So now we will continue from what we have. So this is, so in fact we can even forget this term for the moment, okay, and just work with these guys. So is the next step needed or I can jump? Okay, let's see. So yeah, let us do this. So this is we can say it's proportional because I'm going to drop this C term, but carefully bring it back again. Okay, so this is exp minus half minus 2 square root of alpha t xt minus 1 alpha t plus alpha t minus 1 squared divided by 1 minus alpha t plus t minus 1 squared alpha bar t minus 1 minus 2 square root of alpha bar t minus 1 x naught divided by 1 minus alpha bar t minus 1, and then close this. So I have dropped the C term, okay, but you should not mind that because I will carefully bring it back just to keep the expression simple here. So what we have done here is, it seems very simple, so I just separated this out. I have separated the t minus 1 terms out. Okay, so very simple calculations here. And so what I'm going to do is I am going to take t minus 1 squared term is there. Okay, I see that, but I don't see the t minus 1 anywhere else. Okay, so alpha t, oh, this was x. So let's see. So here minus alpha t xt minus 1 plus alpha t xt minus 1 whole squared, and there is 1 xt minus 1 whole squared here. Okay, so this, so xt minus 1 squared can be taken common, and I believe we will take another one as xt minus 1. So basically here we will take xt minus 1 common and then xt minus 1 squared common. So that's the next step. So we have equal to exp of minus half and then alpha t divided by 1 minus alpha t plus 1 by 1 minus alpha bar t minus 1, and this is xt minus 1 squared minus 2 of square root of alpha t divided by 1 minus alpha t, and then this is xt plus square root of alpha bar t minus 1 divided by 1 minus alpha bar t minus 1 x naught, and then this was with xt minus 1. I have taken xt minus 1 squared common, so t minus 1 squared common, so I have alpha t by 1 minus alpha t and 1 by alpha bar t minus 1, that's right, and then xt minus 1 and with the 2 it's taken common. So then we have alpha bar t xt divided by 1 minus alpha t, and then we have alpha bar t minus 1 x naught and 1 minus alpha t minus 1 is correct. Okay. So then basically I have just combined the first term basically. That's the next step. So in the third and the second term remains as it is. Okay, so we will just multiply this, make it one term. So this is exp minus half alpha t alpha bar t minus 1 plus 1 minus alpha t divided by 1 minus alpha t 1 minus alpha bar t minus 1 xt minus 1 squared minus 2 square root of alpha t xt 1 minus alpha t alpha bar t minus 1 divided by 1 minus alpha bar t minus 1 x naught xt minus 1. So we have not done anything with the second term, but we have just simplified or combined the first term, and we expect some compact representation of this in the first term. So let us see what is that. So if we multiply this, all are alpha here, right? So alpha, and then alpha t times alpha bar t minus 1 will become alpha bar t. Okay. So the way alpha bar is defined, these are products. So if I add one more term, which is the t, then it will become alpha bar t, and other things remain the same. So I guess that's the only thing I'm doing as a next step. Okay, so I'm going very slow, step by step, but let's see. So this is alpha bar alpha t minus alpha bar t plus 1 minus alpha t, but alpha t will also get cancelled, right? Plus 1 minus alpha t divided by 1 minus alpha t 1 minus alpha bar t minus 1, and this is xt minus 1 squared minus 2 square root of alpha t. I just copy this second term, alpha t alpha bar t minus 1 1 minus alpha bar t minus 1 x naught xt minus 1. Okay. So it seems that alpha t should get cancelled. So I will be left with 1 minus alpha t only, alpha bar t I mean. So then a simplified form is exp minus half alpha bar t 1 minus alpha t 1 minus alpha bar t minus 1 xt minus 1 squared minus 2 square root of alpha t xt divided by minus alpha t alpha bar x naught divided by alpha bar t minus 1 t minus 1. Okay, and then the next step, what I will do is I will take this guy common, okay, and common through everything. Okay, so then yeah, so some changes will happen here and here. Okay, so let us do this. So this is exp minus half 1 minus alpha bar t 1 minus alpha t 1 minus alpha bar t minus 1. So we have taken this common, then we are left with xt minus 1 squared minus 2, and then this guy is on the numerator. So alpha bar t xt 1 minus alpha t square root of bar t minus 1 x naught 1 minus alpha bar t minus 1. So this in the numerator, and then it gets divided by what I took the common. Okay, so this gets divided by 1 minus alpha bar t divided by 1 minus alpha t 1 minus alpha bar t minus 1 and whole thing with xt minus 1. Okay, so we took this common, and then this guy remains with 1, and then this gets divided by this guy. So we can kind of combine them. So we will have 1 minus alpha t times 1 minus alpha bar t minus 1, and that gets cancelled with this. Okay, and this gets multiplied with this gets multiplied with this. So there is some simplification here. Let us do that. So this is exp minus half, and this I can see this as 1 by so what we have after that is square root of alpha t 1 minus alpha bar t minus 1 xt plus square root of alpha bar t minus 1 1 minus alpha t divided by 1 minus alpha bar t, and this is with xt minus 1. Okay. So what we have done are these two changes. Like I have written this as 1 by this, so this is same as this. I just written it in this way, and then here I have combined. So this got multiplied and got cancelled with this. So I am left with 1 minus alpha bar t, and this gets multiplied with this 1 minus alpha bar t minus 1 square root alpha t xt, and this gets multiplied with this. Okay, so this is the yeah. So where did the x naught go, right? So x naught should be there, right? So x naught should be there. That's what is missing. All this, why we are doing this is that we want to see whether everything looks like some normal again. So normal distributions are like exponential of x minus mu whole squared and so on form, right? So this did not become a square yet, right? It became like x square minus this, x square minus something. Okay, so to see this as a normal distribution, I need something like x minus mu whole square form here. Okay, so it seems like we won't be able to make it, but then we recall that c term, right? The c term that we dropped before to make the thing simple. Now we will bring that c term, and it is interesting that when we bring that c term, this becomes a square. Okay, and once it becomes a square, then I can read out the mean and the variance from there. Okay, so we may have to leave it here for the moment, and our goal is that all this simplifies to something normal, and that's why we are kind of trying to formulate things in a way that it's some x minus mu whole square form. So what we propose, so what I will do is that I will propose it, and then I will prove the proposal. So I will say that from here onwards, including the c term that we dropped, this will be a normal distribution with the mean that I'm going to write down. So our proposal is that this is a normal distribution with sample xt minus 1 and square root of alpha t 1 minus alpha bar t minus 1 xt, and then plus of square root of alpha bar t minus 1 minus alpha t x naught divided by alpha bar t, and then the variance is 1 minus alpha t 1 minus alpha bar t minus 1 minus alpha bar t. Okay, so this is our proposal. We have not come here yet. Okay, but so basically you have to rearrange this in a way that the PDF of that is this. Okay, so this is what we are supposed to do, and that's where the C term will be useful. Okay, so the first step we recognize is that we need to make it a square. Okay, so to complete a square, so that's where we will bring the C term. So what we believe is that if this is the normal distribution that we are going to have, then the mean, the power of the exponential that we have, okay, which is should be a square. So basically, the exponential of xt minus 1 minus this mean squared, okay, should match this term with the C term added. Okay, so what I want to say is the following. The claim now is that xt minus 1 minus, so basically we will see what this square means, right? So xt minus 1 minus mu whole square, we will try to calculate this, and then we will compare term by term where which terms are okay and which terms will be brought in with the C. Okay, so 1 minus alpha bar t minus 1 xt plus square root of alpha bar t minus 1 minus alpha t x naught, and this is divided by 1 minus alpha bar t. And what we are trying to do is that we are multiplying this with itself. Okay, so basically what we are asking for is a square of this is equal to xt minus 1 squared minus 2 square root of alpha t 1 minus alpha bar t minus 1 xt square root of alpha bar t minus 1 minus alpha t x naught divided by 1 minus alpha bar t, and then plus we bring the C term, so 1 minus alpha bar t divided by 1 minus alpha t 1 minus alpha bar t minus 1, and then C of xt x naught. So that's why I said if you have taken the notes, then remember that this term was taken common, right? And so before, if this term was taken common, there was a C term here. Okay, so here there were like plus C xt x naught. So since we took this guy common, the inverse of this will multiply with the C term that we dropped. So that's what we did. The inverse is multiplied with this term. Okay, so this C was sitting here, but then we took an inverse of that. So the inverse of the common thing multiplied with C, that plus these terms should match the xt minus 1 this whole square term. Okay, if it matches, then we prove the claim that indeed this is a normal distribution with the mean and variance like that. Okay, so hence we have to do a check of this claim. So in this you will see that so the first term is the matching one, right? So xt minus 1 square is already matched, and I believe this second term is also matching. Okay, so the second term of this will be minus 2 I think yeah, xt minus 1 was missing, right? So this xt minus 1 should be here. So this whole thing multiplied with xt minus 1. So this is the term which is here. So this indeed seems to be the case that second term is also there, right? So 2 times xt minus 1 square root alpha t 1 minus alpha bar t minus 1 xt plus alpha bar t minus 1 minus alpha t x naught. So the second term is also you have already. So to do this check, now the only thing now you need is that this the last term, right? So this term, right? The b square term, let's say a minus b whole square. So all the terms are there, but b square term, so these terms are already checked. So only thing you have to check is that now this guy will be equal to the b square. So in this case, the b square is this guy squared, should match with this. If you can prove that, then indeed it's the correct correct mean. So let us do that. Now we will focus on the last term now and try to claim that this. So now we will recall the C that we wrote, right? So the C that we wrote last time could be now written as C xt x naught, and this can be written as 1 minus alpha bar t xt squared plus 1 minus alpha t, and alpha bar t minus 1 x naught square minus 1 minus alpha t xt squared, and divided by 1 minus alpha t 1 minus alpha bar t plus alpha bar t 1 minus alpha t x naught square minus 2 alpha bar t 1 minus alpha t x naught xt. So you can check that the C expression that I wrote. So basically this was the whole thing. So maybe on my notes it's split, but then I think I should just write it here. So this is like this, plus alpha bar t 1 minus alpha t x naught square alpha bar t I mean these are just simple things but long. So now we will take xt square common, alpha bar t minus 1 plus alpha t xt squared plus alpha bar t minus 1 alpha t alpha bar t alpha t, and then x naught square minus 2 alpha bar t 1 minus alpha t x naught xt, and then 1 minus alpha t 1 minus alpha bar t. So here what we have done, we have just taken common. We have taken xt common, xt square, and then x naught square and x naught xt common. Okay, so I think we will factor this now, and the reason is that alpha bar t can be written as alpha t times alpha bar t minus 1. So that will help us to factor this. So this is 1 minus alpha bar t minus 1 1 minus alpha bar t xt squared. So you see this can be written as 1 minus alpha t minus 1 bar minus 1 plus alpha t. Now you take alpha t common, so xt square we took common, then 1 minus alpha, right. So I have written this in factor form, so is this correct or not, right? So this is 1 minus alpha bar t, that's right, and minus alpha bar t minus 1. So why did I do that? 36. So yeah, xt squared, if I take common, then 1 minus alpha bar t is there, and then minus 1 is there, then plus alpha t is there. So okay, so this should get cancelled, right? Alpha bar t minus 1 will be taken common, okay, and then x naught square is there, okay. Yeah, let me just check what, at least the expressions should be correct. with the x naught square I have, I think the starting point is not correct. I think what happened is in my notes I had some calculations, but they were wrong in the sense that the C I did not use in correct form, and then later on I started with the correct expressions. So what I will do is that I will start with the correct one. So this was not the starting point. This was an error I made in my notes, and then I started again later on, and that's the correct one. So let us start with the correct one. Yeah, let me complete this, and then you can watch this video. As I said, these are simple things, but it's very hard to start again. So 1 minus alpha bar t minus 1 minus alpha bar t plus alpha bar t minus 1 minus alpha t 1 minus alpha bar t x naught square minus 1 minus alpha t 1 minus alpha bar t minus 1 xt squared, and then we have so we will use this as well, I think. Okay, so for the moment, yeah, I have to complete this calculation today. So this is minus alpha bar t x naught square 1 minus alpha t, and then 1 minus alpha bar t minus 1 plus 2 square root of alpha t 1 minus alpha t 1 minus alpha bar t minus 1 x naught xt. Yeah, so it's a reasonably long, right? I mean, not too manageable, right? 1 minus alpha t 1 minus alpha bar t 1 minus alpha bar t minus 1. So this is the C. We have I did a calculation mistake the last time. It's a little bit longer this time. So the C I have written, that's why I said I have written C in the notes. You take that expression for C, and this is only C, not the one that multiplies in the front. This is only C, and this is what it comes out. And then here then I will take things common. So let us say I take x naught common. So this is equal to alpha bar t minus 1 1 minus alpha t 1 minus alpha bar t x naught square 1 minus alpha bar t minus 1 1 minus alpha bar t minus 1 minus alpha t 1 minus alpha bar t minus 1. So this goes with xt squared, so we are taking common, and then we have minus alpha bar t 1 minus alpha t 1 minus alpha bar t minus 1 x naught square 2 alpha bar t 1 minus alpha t 1 minus alpha bar t minus 1 x naught xt. All these things divided by 1 minus alpha t 1 minus alpha bar t and 1 minus alpha bar t minus 1. Okay, so we have taken x naught square common. So with the x naught square, where are the x naught squares, right? So we see that x naught square is here, and x naught square is here. Okay, but I mean, I have not taken it common yet. I don't even know what I did. So it seems like x naught square, one term is here, which is this term, right? So this term is there, x naught square. If we take x naught square, this is x naught square term, but then x naught square term is the other one is also here. I did not really take the common. So and then xt square, xt square, it seems I have taken, but there is only one xt square, right? And what did I, okay, I missed this xt square here, right? So this is xt square here. So that's why this xt square, another term is here. For this xt squared, 1 minus alpha bar t minus 1 minus alpha bar t, and then minus 1 minus alpha t 1 minus alpha bar t minus 1. So only xt square has been taken common in this step. Okay, other terms remain the same. So you just focus here, xt square. So basically this guy and this guy has been combined. So I hope like you can do this again, like recheck this. In my notes it's okay, like I have carefully checked these things. So in the papers, like they don't do this full derivations, okay? So you are supposed to do these things. So, but I have checked that my derivation is okay, like everything comes out to be exactly the claim, okay? But here I may do some mistakes, but then you may double check again, okay? So this is what we have, xt square, x naught xt, right? And then the next step is, it's like I'm going very slow because I was doing derivations, I was doing step by step. So then in the next step I take x naught common, okay, x naught square common. So this is alpha bar t minus 1, 1 minus alpha t, alpha bar t minus alpha bar t, 1 minus alpha t, 1 minus alpha bar t minus 1, and this goes with x naught square and plus 1 minus alpha bar t minus 1 and 1 minus alpha bar t minus 1 minus alpha t, 1 minus alpha bar t minus 1, and this goes with xt squared, and then the remaining term is 2 square root of alpha bar t, 1 minus alpha t, 1 minus alpha bar t minus 1, x naught xt, and then the whole thing divided by 1 minus alpha t, 1 minus alpha bar t, and 1 minus alpha bar t minus 1. So in the next step, as you can see, I have taken, in the first step I took xt square common, and in the second step, like I'm going very carefully, okay? So in the second step I took x naught square common. So now you can focus on these two guys, and hopefully we have taken the common in a correct way. So alpha bar t minus 1 minus alpha t, 1 minus alpha bar t, and then this is minus alpha bar 1 minus alpha t, 1 minus alpha bar t minus 1, that's correct. And the remaining, the 2 alpha root 2, it always remains the same, okay? Okay, so now it seems like some cancellation is happening in the xt square term. So let us see that why the cancellations happen. In the x naught term, we can take 1 minus alpha t common, okay? That's the next step. So here I will take 1 minus alpha t common, this guy is here, this guy is here. And in the xt square term, I took 1 minus alpha bar t minus 1 common. So here this guy is the common, and then this 1 gets cancelled, 1 minus plus 1 and minus 1, and here we took 1 minus alpha t common as a next step. So in the next step we have 1 minus alpha t and alpha bar t minus 1, 1 minus alpha bar t minus alpha bar t, 1 minus alpha bar t minus 1, x naught square, and then plus 1 minus alpha bar t minus 1, 1 minus alpha bar t minus 1 plus alpha t xt squared plus 2 square root of alpha bar t, 1 minus alpha t, 1 minus alpha bar t minus 1 x naught xt, and all divided by 1 minus alpha t, 1 minus alpha bar t, and 1 minus alpha bar t minus 1. So we did this 1 minus alpha t common, as I said, in the x naught term, and 1 minus alpha bar t minus 1 in the xt square term. And clearly here there is a cancellation here, so that's fine. I think that's the only thing left. It's like we are almost there, like just 2-3 lines more. So here you can take alpha t common, and this guy is a product, right? So you take alpha t common, then you will have 1 minus alpha bar t minus 1 coming out from here after taking alpha t common, and that makes it a square here. So let us do this as a next step, and it seems like everything else remains the same. One more thing is done is that this is a product, this is a product, so I take alpha bar, so there is alpha bar t minus 1 common here, right? So I take alpha bar t minus 1 common, so that's one step. And second step is alpha t common, then we will have 1 minus alpha bar t, and 1 minus alpha bar t will become square. So that's our that is our next step. Okay, these two changes we will do. So we take alpha bar t minus 1 common, one minus alpha t, and then 1 minus alpha bar t minus alpha t, 1 minus alpha bar t minus 1 x naught square plus alpha t, 1 minus alpha bar t minus 1 squared xt squared plus 2 square root of alpha bar t, 1 minus alpha t, 1 minus alpha bar t minus 1 x naught xt. Okay. Okay, so these are the changes we did, and then we are kind of close now. So it seems that some cancellation is happening here as well, because you have minus alpha bar t here, and this alpha t multiplies with alpha bar t minus 1 to make it plus alpha bar t. So minus alpha bar t plus alpha bar t gets cancelled, and 1 minus alpha t remains. 1 minus alpha t remains. So 1 minus alpha t squared is found here. Okay, and it seems like it's of a plus b whole square form with the, I believe you can take a square root of this, and then it becomes a squared plus b squared plus 2ab. In the paper they will only say that putting back the c completes the square. So for the last 40 minutes what we are doing is not in the paper. Okay, it's like so papers are like this, they write it very short, and you have to fill the details. So this is equal to alpha bar t minus 1, and this is 1 minus alpha bar t So saving my voice a little bit. So this is where we leave it, where we kind of see this. We kind of see a square happening here, and remember that in the C we had to multiply some term on the C. So the effect of that will be that some of these denominator terms gets cancelled due to that effect. So let us recall that fact. So what we have done is this is just the C part. Okay, we have kind of rearranged things in a way that, so this is exactly C x t x naught that we started with. So this is a simplified expression for C, and then what we had to look at was 1 minus alpha t, 1 minus alpha bar t minus 1 divided by 1 minus alpha bar t, and C x t x naught. So if you recall, this term is what we were saying that it will be equal to that b squared that we are talking about. So if we now look into this, then this becomes, so basically this and this is in the denominator here, so those two gets cancelled. Okay, so then, and basically in the denominator this was one of the term already there also, and so that makes it a square. So overall it becomes alpha bar t minus 1 minus alpha t squared alpha t 1 minus alpha bar t minus 1 squared x t squared plus 2 square root of alpha bar t 1 minus alpha t 1 minus alpha bar t minus 1 x naught x t, and this is divided by 1 minus alpha bar t squared. Okay, and then now we can write this as square root of alpha t 1 minus alpha bar t minus 1 x t alpha bar t minus 1 1 minus alpha t x naught divided by 1 minus alpha bar t, and this is the whole thing squared. And if you can recall, this was the b square term in the normal distribution that we were talking about. So if you recall the claim that we started with, so now it's a, now you have to like look into this, and this is indeed the this indeed gives you the third term that we were trying to check in the, so this is the, so I can write it as is the third term of, okay, just for the sake of the notes I will write down, although it followed from the claim itself, but just, so this gives the third term of the expression x t minus 1 minus square root of alpha t 1 minus alpha bar t minus 1 x t plus square root of alpha bar t minus 1 alpha t x naught divided by alpha bar t. Okay, so what was there in the claim is that we saw that the two terms of this square, okay, basically it's a square. So what we saw is that the two terms of the square of this we already found, and the third term we claimed was coming from this, and which is exactly the case we have proved here, that this is equal to the third term, which is the b square term, a square minus 2ab plus b square is exactly this. So this means that indeed bringing the c indeed completes the square, and that square is this, and this then also means that the mean of the final normal distribution will be this minus of the whole thing. Okay, so that proves that the mean will be that. Okay, and the variance will be, because in the variance we have like it's like 1 by 2 sigma, right? So this will be like a variance. So our claim was in terms of the normal distribution, right? And so let us see in the form of the normal. Yeah, we wrote the normal distribution, and so that's what I'm. So this 35 should be 34. So what we claimed is that the mean is this, which is what we have found, and then the variance will be, yeah, we have to fix the variance as well, but let's see, variance should be there because it's in the scaling that we did before. The variance should come from there as well, because in the beginning we took so if you recall, the variance can also be fixed, because if you recall where we left last time, this is just the last point, okay, then we are done with this and we will stop. So if you recall, where we left last time was this exponential of minus half of 1 by 1 minus alpha t and 1 minus alpha bar t minus 1 and divided by 1 minus alpha bar t, and we wrote it like this, and then inside we had this term xt minus 1 squared minus basically this term, okay. So this is where we left last time, and we dropped the c term, but then after bringing the c term, we have that it becomes a square like this. So basically this is the mean that I can find from here, okay, minus of the whole thing. So that's the mean, and for the variance it's like exponential of minus 1 by 2 sigma, right, and x minus mu whole square. So this guy now multiplies with this guy to have the variance, okay. So this is like x minus mu, we have squared it, so this is like x minus whole squared, and this guy is also squared, okay, but this is in the denominator, so one of the square gets cancelled, okay. So then the variance becomes 1 by 2, and whatever is there here, it's the sigma term that we are looking for, okay. So that's the form. So this becomes minus half xt minus 1 minus mu divided by sigma, where mu is this guy, which is square root of alpha t 1 minus alpha bar t minus 1 minus square root of alpha bar t minus 1 minus alpha t x naught, and the variance is this guy by this, because one of them gets cancelled anyway, so it remains 1 minus sigma alpha t 1 minus alpha bar t minus 1 divided by 1 minus alpha bar t, okay. So from here what we have proved is that this is indeed the overall we have a normal distributions with the mean mu and the variance like that, okay. So just to conclude, we have done a complete derivation of this. So just to conclude that we were looking for in the third term of the elbow, we had this term qt minus 1 in the KL divergence, right. So then, so what was that term we were focusing on? We started with q xt minus 1 xt x naught, and we found that this is the normal with xt minus 1 as a sample and mu and sigma as defined there. So the whole point was that this can be calculated. So now we can say that, okay, this is a normal distribution with that mean and variance, Okay, and we had the other terms we already calculated, xt x naught. So we had the normal distribution for this, and obviously also for this. So we had all this. I mean, yeah, that's right. Yeah, so we have, so I mean, what I want to say is we have expression for this via this, and yeah, basically in the intermediate term we also had this, but the point was this guy, which is which was from the base rule xt minus 1 x naught q xt minus 1 x naught divided by q xt x naught. So our goal was to compute this in the last term of the elbow, where we had KL of this with the p theta, right? So that's where we were. We started from elbow. Last term there was a sum term, and then we had a KL of this with the p theta xt minus 1 xt. Then we said, how are we going to calculate this? Okay, so then we say, okay, let us go to the base rule, and then from the base rule, because reverse thing is something we cannot, we don't know, right? But the base rule, the good thing about base rule is that you can do the other way. So this can be written this way. So the forward process is kind of known because it's a normal distribution, right? And then these are all forward processes, and they are normal distributions. So we had expressions for all this. We put a normal here, and we did a lot of simplifications in the exponentials, powers, and so on. And finally we found out that the whole thing is a normal distributions with mean and sigma. So now this will help us in the KL divergence term that we have with q xt minus 1 xt, and then we were comparing with p theta xt minus 1 xt. Okay, so our next step will be the fact that we have expression for the KL for the normal distribution of this, and we will assume a parameterized normal distribution here, and we will find a KL complete KL expressions for this. Okay, so that we will do in the next class, but this was a long calculation, and then this is not that long. So this is the summation part is the most heavy, I mean the most important part, and with this we will, if we know how to have a closed form expression for the KL, then we are more or less done. So let us stop for today. It was a little bit long, but we completed the major calculation today. The other steps are not that big. Okay, thank you.